About implicit derivative. An implicit derivative is very interesting because not all the time that you take a derivative is exactly the function that you're expecting. So for example, like maybe square root of x, x to the 3/5 power.
23.
Okay. So what is implicit derivative? So we're going to talk about how do we take a derivative like d to the dx of x to the cube. And you already know how to do this, implicit derivative. Implicit. Okay? You already know how to take a derivative of this, right? We know the answer is what?
X squared.
But you didn't know it yet. Because those actually chain rule occur here that you don't know about. Because you're going to take derivative of x cubed. So this means derivative respect to x.
Oh.
You can do derivative respect to y and be completely different. So this is derivative respect to x. That means every time you take a derivative of x cubed, I'm going to get 3x squared. And then what I'm going to do is, I'm going to do, what if there's a chain rule? I had to take a derivative of x, right? What's derivative of x? Was 1, but y is 1 because it's actually multiplied by the dx over dx. Because I'm going to take derivative of x respect to x. But dx over dx is what? 1. So my answer is 3x squared times 1. But we usually forget that 1. We just assume that it's there. Okay? So now we're going to take a derivative of y to the third. Now this one's a little bit different. This one is a bit different. Now if I'm trying to take a derivative of the y cubed, then I'm going to get 3x squared, the 3y squared, which is, that was the power rule, right? And then we're going to take d to the dx to the y. In this case, it was d to the dx to the x. If I take a derivative of x, it's going to be 1. But here it's going to be dx over dx, but here it's not dx over dx. It's what? dy over dx, which is, that's a change in x over changing y over changing x. So in this case, I'm going to get 3y squared dy dx. So unlike before, anytime you take derivative of y, you're going to have a dy dx as a byproduct now, due to the chain rule. Okay? So how do I take a derivative of this function? We're just taking derivative of the expressions. Respect to x now. I'm not always taking derivative with respect to x. In next section, we're going to take derivative with respect to angle, to area, volumes, height, all kind of stuff. So only y is going to create a dy dx. So what's derivative of 3x squared? 6x. Yeah, that was fairly easy, right? Now this is a negative 6 times derivative for the y. So I'm going to keep the negative 6 outside here. Do you see that? I'm going to take a derivative of y to the 4. So what's derivative of y to the 4? 4y cubed dy dx. See that dy dx? You cannot lose that piece. And if you lose that piece, then you're going to get it wrong. So 6x minus 24 y to the third, and then dy dx. Yeah? I put it in the back.
Oh, okay. 24.
So this is one that you're gonna forget. If you dx over dx, that's just 1. That has no difference. But the one problem is y. If you take a derivative of y with respect to x, I'm gonna get dy dx. Now, why are we doing that? We have f prime of x. That means that's the slope, which is the rate of change. And then we have another notation represent the same thing, because that's also the same notation, which is dy dx. Sometimes we're going to use this notation, y prime. That's also a derivative of y. This is a derivative of y with respect to x. This is y prime, which is take derivative with respect to x. Derivative with respect to x. This all means the same thing. This means all f prime of x. Okay? Now we're going to give you a function that says y to the cube minus xy to the second is equal to 6. I'm going to do 2 here. Okay. So what I'm going to do is I'm going to look at this. We're going to say, Anthony, can you plug in the decimals and just type in like this, exactly like this.
Okay, guys, I'll find you guys.
Hopefully that's an interesting graph. Y cubed minus 2xy squared
Yes, dy.
is equal to 6. Okay.
No, that's not.
Zoom in a little bit. Okay, so yeah, turn off. So the graph is gonna be like this. The graph is like this. Okay, so obviously that is not a functions, because if you draw a vertical line test, it will fail. But however, you still can take a derivative of those functions. Okay, you still can take a derivative of non-functions. Even a square is not a circle is not a non-function. It's a non-functions because a circle you fail vertical line test, but you still can take a derivative. Okay. We always stand behind me. Okay. So now we're gonna take a derivative of this. So can you turn on the light again? So what I'm gonna do is I'm gonna take d to the dx to this whole thing. Okay, what's the derivative of the y cubed respect to x? 3y squared dy dx. Does that make sense?
Yes.
Now what I'm going to do is I'm going to draw a parenthesis right here for this -2. A lot of you guys don't understand that parenthesis is very, very important. So yes, I just changed it to. So there is a parenthesis right here before the 2. That 2 is going to be there. So what I'm going to do is I'm going to leave that -2 alone. Just the way it is, I'm just leave it outside. And now I'm going to take a derivative just the red part. Does that make sense? Mm-hmm. If I take a derivative of just the red part, what am I going to get? Well, I'm going to take a derivative of x with respect to x. What am I going to get?
1.
Y squared, right? Times 1.
Okay.
Plus, okay, we're going to write this part in red. So there's a product rule, good. So there's a product rule here happen because x, y squared, there is a product. A product is derivative of x is going to be 1, and it's going to be y squared times 1 plus what? X, 2y, and then dy dx.
So every time to y, we have to put dy dx.
Pretty much. Now on this side it's going to be what? This side is going to be what? 6? 0. A lot of you guys kind of forget that part. Derivative of 6 with respect to x is still equal to 0. So now I'm going to distribute this. So I'm going to say 3y squared dy dx minus 2y squared minus 4xy dy dx is equal to 0. I distribute it because they're inside. Now, what am I looking for? I'm looking for this, the dy dx. I'm going to underline this. That means this need to be on one side. Everything else that doesn't have dy dx, I'm moving to the other side. So which one doesn't have dy dx? So I'm going to add 2y squared, right? So on both sides, so I'm going to get 2y squared. And that's equal to, and I'm going to take out a dy dx outside, which that's what I'm trying to solve for. If I take it out, what do I have left? 3y squared minus 4xy. And then I'm going to divide it both sides. I'm going to get dy dx. I'm going to get dy dx is equal to 2y squared over 3y squared minus 4xy. And that's it. We just take a derivative of the thing. Okay. We're going to ask you to practice one.
Oh.
Wait, if you added
just divide it out.
if you added 2y squared over there on both sides, how did you still have 2y squared?
I'm adding 2y squared. I'm adding 2y squared on this side.
Right.
So this one's going to go away.
Yeah. So then why did it still say 2y squared minus 4?
It says 3y squared.
Yeah. How did you have?
Because
This
there's
one's
3y
3y
over there.
squared.
He factored out the dy dx.
I factor out dy dx principle. So there was an intermediate step. Let me write down the intermediate step. I can't jump step. So it's going to be 3y squared dy dx minus 4xy dy dx
Why not have water, bro?
is equal to 2y squared. And I'm going to take out dy dx.
You're right.
Yes.
So dy dx is a number? It's not supposed to be like
dy dx is a derivative of the function.
Is that all?
And though this function is not a function, but it still can take out a derivative.
Okay. And the function is the slope.
Yes, the x minus x is the slope of function, the rate of change.
And then the slope is supposed to be whatever.
But I can't say.
No, unless you plug in the values.
Okay.
It's green. Okay.
Why can't you say you do that?
Yeah, but like,
How's your
you
check?
go and walk.
Corny, you get that going?
I want to stay here. Oh yeah, I like to that.
No, but what do you actually do?